Hello everyone. Today our topic is chemical kinetics. Today we shall learn how to solve the rate constant or the half-life period of a reaction. So the formula that we are going to use today is this is the first formula that we are going to use. T half is equal to 0.693 by K. This is a half-life period for a first order reaction. So if they ask you to calculate the half-life, so this is the formula that you're going to use. T half is equal to 0.693 by K. We also have another formula that is this is the expression for a first order reaction. So this is another formula that we have. K is equal to 2.303 by T log A naught by A, where A naught is the initial concentration. Initial means the starting concentration, and this is the final concentration. So in some textbook, this may be written as R and R naught and R. So remember, this is the initial concentration and this is the final concentration. So these are the two formulas that we should keep in mind while solving the numericals. So here is our first question. A fast order reaction takes 40 minutes for 30% decomposition. Calculate its half-life. So in order to calculate half-life, what do you need? T half, this is the half-life. In order to calculate half-life, you need K, rate constant. But that is not given in this question. So first, from this expression, from using this formula, we shall find K, since this is a fast order reaction. So we'll find K, and that K, we shall use it to find T half. So out here, the given from the question is time is given, which is 40 minutes, and for 30% decomposition. So now what I shall do is I'll write down the formula. K is equal to 2.303 by T log A naught by A. So now let's write let A naught be A. Let A naught equals to A, and A will be what? A will be A minus X A. So this kind of a formula out here. A naught will take it as small a, and A will be A minus XA. So out here A minus, so now what is this X? This is the percentage of decomposition. So how much? 30%, right? So this X will be 30, since it is percent, 30 by 100 A. Since it is in percentage, you can write 30 by 100 A. So now you take the LCM, 100 A minus 30 A equals to 70 by 100 A. So I'll just keep it like this guy. 70 by 100 A. I hope till here you understand. Let A naught be A, let A naught be A be A minus XA. Now these values I'm going to put it out here. So I can write, since we are finding K, 2.303. So now what is the time? The time is 40 minutes. 40 log, what did I take? A naught is small a, and this is 70 by 100 A. Now A and A, I can cancel them. K is equal to 2.303 by 40 log. Now this 100 can go up here, so it will be 100 by 70. This one can go outside. K is equal to 2.303 by 40 log 100 minus log 70. So whenever it is like this kind and you're supposed to take log, it will be log A minus log B. So log 100 minus log 70. The upper one minus the lower one. So K is equal to 2.303 by 40 into 100 is 2, log 100 is 2, log 70 is 1.8450. So K is equal to 2.303 by 40 into, so if you subtract these values, you will get 0.155. So now K will be, now you multiply these two and divide by 40. Or if you don't want to multiply, you can take log and anti-log and then calculate as well. So if you multiply these two, you should get 0.356. 0.3569, or you can write 0.356 divided by 40. So if I divide these values, you get so you will get T is equal to 0.0089, or else you can also write or 8.9 into 10 to the power minus 3. So now what is the second part of the question? Second part of the question is to find half-life. So T half is equal to 0.693 by K. So now we already calculate K. So T half is equal to 0.693 by 0.0089. So your T half will be, so our T half will be 77.8 minute. So T half will be 77.8 minutes. So if you divide this one, you will get 77.8 minutes. So this would be our answer. So now let's try our next problem. A fast order reaction is 20% complete in 10 minutes. So 20% is completed in 10 minutes. So calculate the time for 75% completion. For 75% completion, what is the time? So at the last, you're going to find T. So out here from this reaction, T is given. You're supposed to find K from the first part of the equation. If T is given, you will find K. If K is given, you will find T. That's quite simple. So it is 20% completion and 10 minutes. So let's start again. We'll write down the formula. K is equal to 2.303 by T log A naught by A. So we are going to use this formula. So again, let's say let A naught is equal to A will be A minus XA. So A minus 20%, 20 by 100 A. So we have 80 by 100 A. So now let's put in the formula. Time is 10 minutes. So A and A will get cancelled. We'll have K is equal to 2.303 So now log 100 is 2 and log 80 is 1.9030. So if you subtract these two numbers, you get 0.097. So now you multiply these two. So if you multiply these two numbers, you get 0.223 divided by 10. So if you divide by 10, 0.022. I'll not take 3. I'll just leave it till here. If you want, you can take 3 also. So k is equal to 0.022. So now we get the k value. So what is the second part of the question? Second part of the question is calculate the time for 75% completion. So now we will calculate time t. So I'll write down the formula like this kind. T is equal to 2.303 by k log a naught by a. Since we are going to calculate time, so I just change their place. So t. So far before that, let's do it again. A naught is equal to a. A will be a minus xa. So a minus 75%, 75 by 100 a. So you'll have 100a minus 75a. So you'll have 25 by 100a. So now t is equal to 2.303. So what is the k value we get? 0.02. A by 25 by 100a. A and a you get cancel. 2.303, 0.022 log 100 by 25. So t is equal to 2.303 log 100 is 2, log 25 is 1.3979. So now if you subtract these values, you get 0.6021. Again, you multiply these two numbers, you will get, if you multiply 1.3866 divided by 0.022. So t will be 63 minutes. So basically it means that for 75% completion it took 63 minutes. For 20% it took 10 minutes. For 75 it took 63 minutes. So this will be our answer. So the answer is quite long. First you need to find k, and using that k again you find t. So out here the numbers are quite big. As I've said earlier, if you want you can take log and then at the end you take log and you can get the values. So now let's try our next problem. A fast order reaction takes 69.3 minutes for 50% completion. So 50% means it is half of 100%. So directly we can go for t half. Whenever is given 50%, you directly go for t half. Calculate the time required for 80% completion of this reaction. So from these two we can find k, and using that k again we shall find t for 80% time. So since it is 50%, you can directly go for t half. If it is not 50%, then you can do it like the previous one. Or else if it is 50%, go for t half. T half for 69.3 minutes. So you can write t half is equal to 0.693 divided by 69.3. Oh, sorry, I'll just write down the formula first. T half is equal to 0.693 by k. So k will be 0.693. What is t half? 69.3. Why? Because this 50% completion, this is the time. So you divide this one, you will get, so if you divide this one, you will get 0.01. So now we get K. Let's try. What is the second part of the question? Calculate the time required for 80%. So now let's write down the formula again. First order reaction, 203 by T log A naught by A. So again, let's say that A naught is equal to A is equal to A minus XA. So since it is 80%, you can write A minus 80 by 100A. So it will be 20 by 100A. So since you're supposed to find T, so you can write T is equal to 2.303 by K is how much? 0.01 log A by 20 by 100 A. And A you can cancel. T will be 2.303 by 0.01 log 100 by 20. T is equal to 2.303 by 0.01 log 100 minus log 20. Sorry, log 20. So T will be 2.303 by 0.01 log 100 is 2, log 20 is 1. Log 20 is 1.3010. So if you cancel, if you subtract this one, you will get you will get 0.699. So now you multiply these two and take NT log. Multiply these two and then divide. So if you multiply these two, you will get 1.6097 divided by 0.01. So if you divide by 0.01, you will get T will be 160 minute. So basically it means that for completing 50% it took 69.3 minutes. For completing 80% it took 160 minutes. I hope the steps are familiar to you. If you face any problem, please let me know in the comment section. As I always mention in my videos. So only the two steps. We are always following the two steps out here, right? That A naught be A is equal to A minus XA. First we find K, and then again we put the K values out here to find T. That's all. So the main part which you may face problem is multiplying these numbers because they are quite big and there are decimals as well. If you don't want to multiply, as I've said earlier, you remove the points and then you take log and antilog. I shall do one for you later. So here is our next question. Calculate 2/3 life of a first order reaction having K. So out here K is given, you're supposed to calculate 2/3 life of a first order reaction. So here is how you can solve this question. So K is given 5.48 into 10 to the power minus 14 per second. So K is given. So out here also we can use the same old formula, that is T is equal to 2.303 by K log A naught by A. So now we can say let A naught is equal to A and A is A minus XA. So X will be how much? It is 2/3. 2 by 3A. So you can write 3A minus 2A by 3 is equal to A by 3. 1 by 3A, or you can write 1 by 3A. 2 by third of a reaction, first order reaction. So now calculate 2 third life. So you can write T 2 by 3 is equal to 2.303 by K is how much? 5.48 into 10 to the power minus 14 log A by 1 by 3 A and A can get cancelled. So T 2 by 3 is equal to 2.303 by 5.48 10 to the power minus 14 log 3. So log 3 is 0.4771. So now I'll multiply these two numbers. So if you multiply these two numbers, you'll get 1.098 divided by 5.48 into 10 to the power minus 14. So T 2 by 3 will be, so if you divide this one, you'll get 0.2003. 0.2003 into 10 to the power 14. Since it is 0 points, I'll just move the decimals. If I move the decimals, I can write 2.003. So I move these decimals out here. 2.003 into 10 to the power 13. So T2 by 3 will be this much. So I can write per second. So it will be 2.003 into 10 to the power 13 per second. So if you move out here one time, it will be 10 to the power minus 1. So 14 minus 1 will be 13. So now let's try our last problem. The rate constant for a first order reaction is 60 per second. Rate constant is given, K is given. So how much time will it take? So they're asking you T. How much time will it take to reduce the concentration of the reactant to 1 by 10 of its initial concentration? So you're going to reduce the reaction by 1 by 10 from its initial concentration. So here is how you're going to solve this problem again. So you have formula K is equal to 2.303 by T log A naught by A as always. So out here A naught, we are going to take it as A naught, we are going to take it as A naught itself. We will not change this one. No use of changing. And A is 1 by 10 of its initial concentration. So this is 1 by 10 of its initial concentration, just like the equation. Right? 1 by 10 of its initial concentration. What is the initial concentration? This is the starting concentration. So A will be 1 by 10 of its initial concentration. So K is given, you're going to calculate T 2.303. What is K? K is 60 per second. So I'll write here 60 log, this will be A naught by 1 by 10 A naught. So T is 2.303 divided by 60 log A naught and A naught you cancel, it will be log 10. Log 10 is 1. So into 1, T will be 2.303 divided by 60. So if you divide this one, you shall get, so if you divide this one, you will get 0.038 second. So this is how you can solve, or you can write 3.8 into 10 to the power minus 2 second. So this is how you can solve these equations. So by this I finished few questions from chemical kinetics. So if you face any problem while solving the numericals, you please let me know in the comment section. Thank you.